Last class, we talked about primary index, and now we can talk about something called clustering index. So what is a clustering index? This is the index built based on non-key field. It is also called the clustering field. Okay, and so what is the non-key field? That's basically mean the field you do indexing is not unique, right? So compared to primary index require to be indexing on unique field. This is on non-key field, not unique. So clustering field, okay, do not require to have this thing. That's the one I just finished. And we'll see what this one have is we still have the same structure, an index field and a pointer. And what we have is for each distinct value of the clustering field, we need to have one record here, and then it will have a pointer point to the first block in the data file that has a record for the clustering field. Then when we just talk about this point, you will confuse. How can that possible, right? This is possible because the data file is also physically ordered. Okay, that's another thing important. This is also physical order, and this is a full physical order on this clustering field. So here, it is a physical order based on the clustering field, this non-key field. If it is not this case, you cannot build a clustering index. Similar to primary index, the restriction is the file must physically order based on this field. Let me show you one example and okay, so let's see. See, this is a data file. Okay, so let me draw the data file here. Let's see, the data file is about employee information, and we are going to okay, so we're going to have a couple of blocks here. And my data file, the first field is a department number. And this, it doesn't necessarily to be the first field, the first attribute can be any attribute, like the order of which attribute first doesn't matter. It just makes things easier to draw. So that's why I put this on the beginning. So this data file is physically ordered based on department number. Say for example, number 1. Right, number 1 here, and then I have 3 employee number 1, and then I move on to number 2, and 2 employee on number 2, and I move on to number 3, and so I keep doing this. And I have other things like a name, other things for the data file. So the data file is physically ordered based on the clustering field, that's the number, and this is not unique. This is non-key field, okay? All right, and you can see this can handle the problem that the primary index cannot handle, right? And of course, primary index also handle the problem that this one cannot handle because their data file structure are different. If the data file is physically ordered on the key, you can do primary index. If the data file is physical order on non-key, then you can do clustering index. Okay, so how to build the index? So for the index, this is the index file. And so for my index file, I have a clustering I have a clustering field. And then I have the pointer here, right? So block pointer here. And so this index file can be many blocks. And for clustering field, right? I have couple number 1, couple number 2. I only put each of them once here. and the number 2 here and number 3 here, and we can have other values. So then let's see how to do the pointer. We're going to make the pointer point to the very first block that this record can ever show, right? So this is the first one. And for number 2, this one should point to the same block also. And here, this is the pointer point to the block. So this pointer is a block pointer. It's not pointing to a particular record. It's a point to this whole block. And number 2 point to this block because the first number 2 showing here. So this one show us, actually you will see, so number 3 is actually point to here, right? So it's not point to this record, it's point to this block. So in this one, you will see when I retrieve something, right? So I reading this. So if somebody is in department number 2, I'm going to follow this pointer to go to this one, right? And I need to search within that. I know there's a number 2, but that's not enough. I need to go to the next block, right? So they are continuous. I need to go to the next block and to see if I have number 2 or not until the very last record. If I reach a record different than 2, then I know I'm done in this block, right? See, this is 2. If I change this, if this is 2 until 2, when you read this, you don't know that's the end of it or not, right? In this case, you don't need to know. You don't know until you reach something. For example, there's 1 more, 2, or the first one is 3. Then you know you reach the end of that, right? So this means you may not be able to just reading one block to get everything. Like this one, you can, right? Number 1, you can because you see a 2 at the end, means there's not possible to see 1 anymore, right? Okay, so that's for this one. And so let's see the insert operation. Okay, so we can see when we insert, I want to insert number 1. Okay, then I need this space for sure, right? And 2 has to move down, and then this pointer have to move here. Oh, that's so many steps, right? And so that's why to make insert more efficient, if we want to make insert more efficient, it's usually common to reserve a whole block or class or contiguous block for the value for the clustering field. So if when we organize initial design our system, for example, we want to put in employee information according to their department number, then it is best to just make them into the contiguous blocks. So, like 1 block for number 1. And if it's not sufficient, we can link many number 1 together. So in this way, we don't have to keep moving record between blocks and change the corresponding index. Okay, so let me briefly put this in. So for example, the whole thing for the first one is number 1, and then this whole thing is for number 2, and then this is for number 3. And so if they are not enough, for example, number 3, I have a lot of number 3, I can link to another block. Okay, I run out of space, and then they all, so I can have another block holding number 3 here. So in this way, this point number 1, number 2, and number 3. And here we can have some empty spots. So if I have 3 employee number 1, and I have a couple space here, that's okay. We just keep this empty. So in the future, when we want to insert more, we have space to insert to them. Okay. So now let's see. Let's quickly summarize the clustering index. in clustering index, we require the data file to be physically ordered on a non-key. And we also require the index field, index files, the index field, clustering field must be this one, the one, whoever you physically ordered out, right? Okay, so you can see both primary index and clustering index has some restrictions on the data files. And not only that, because of data file structure, only certain type of index can be built on top of it, right? So in this case, if I want to build things like if this is a data file and I want to build things based on name, you cannot build clustering index on name. You also cannot build a clustering index. You also cannot build primary index on name. It's just because the file structure you already have. So can we do something more than this? And the answer is yes. That is using something called secondary index. So the reason we call it a secondary index is because this one actually provided a secondary mean of accessing the file, which have some primary access already. So when can we build a secondary index? So you can think about this way. Okay? I think the easy way to think about this is, according to the structure for data file, okay, you can build a primary index on a given field based on that. And also based on the file structure, the data file structure, you may also can, depends on which structure you have, like order on key or order on non-key, right? You can also do the clustering index on something, depends on the structure. Okay, anything else can be done by secondary index. So if the file is a physical order based on a key, you can build a secondary index on something not the ordering field. And same thing for clustering index. Beyond this one cover, anything else can be done in secondary index. Okay, and so secondary index allow you to basically be able to build different type of structures or the fields that you like. If you're interested in doing an index on a particular field, and you don't have to physically restrict it by the data file structure. That's the main purpose of that. The index has index field and also has a pointer, so same as what we did. And this one is the non-ordering field of the data file. This is whichever field coming from there, and that block, the pointer can be a block pointer or record pointer. Let's see a couple of different cases, and it can help to understand what this one means. Okay, so the first one I want to show you is a secondary index. The index field has a distinct value for every record. Okay, and so what we have here is, this is, let's see this first and we'll go back. So this is a data file, okay? And I'm interested doing an index on this particular value. Say, for example, this is employee ID. Okay, so this is employee ID, and I can see this data file is not physically ordered on this field. So I can build a secondary index like this. Okay, in this particular case, this is unique, right? So this is unique. So every single unique value will show up as the index field. And they are ordered. Okay, so this is also important. This is ordered. And what we need to do is, for each of the given value, I need to see this is in which data block, right? So this is the disk block here. So that's why this is the one point to this disk block. So means whichever has this number one as employee ID will be somewhere in this block. Okay, so let's see. So we have a block pointer. And so when we search something, we need to search the index file first. And we found the right record, right? Like the number one I show. And we load the block and then we search within the block. So like say, I want to see whose employee ID is number one. So I get number one and then I follow that, I load this block. So searching this number one takes some time, right? Since you use binary search. And then you take this and you will search within, because you're going to load this to the memory, and you will search within the memory to see which is number one, and you got it. Okay. Okay, so this is an example actually show if you use the secondary index. So this is a secondary index, right? So without that, so for example, this example without that, if we do linear search, you will consider average case of half of it. This is how many we need. But if we use a secondary index, right, and we actually only need, in this calculation, only need 10. So it's much smaller number. And the main reason is the index is small, right? Files is small, and also it is older. Okay, so this one has the same number record as this one, right? But this is smaller than each of the record, and also this is a binary search compared to linear search. That's why you have the performance. So this is an example of dense index, right? So remember, we talk about this, seems doesn't make sense. We have dense index because every single one will show here, but now you'll see actually performance gain by doing the dense index. And of course, dense index, it takes more space than sparse. But in this case, for this secondary index, you only can do the dense one because they are not ordered. Otherwise, you cannot find the right disk block. Okay, so that's for one example for secondary index. And in this example, the index field, it is unique, right? Unique. And what happened if I want to do an index on a field and that's not unique? So this is another case of a secondary index on a non-key field. Simply this means you can have many records have the same value for the indexing field. In this case, only one, right? Because this is unique, but this one you can have many of them. Then how can we do that? So there are a couple options to do this type of secondary index. One is we can have several index entry with the same key value, one for each record. Okay, so let me show you one example, and then we'll move on to the 2 and the 3. At least, you can see something that we have more than one, what it looks like. Okay. Okay, so now two, 1, 4, 4. For example, this is department ID for student. And each department has ID, and this is a student record. I want to do an index. So obviously, this is not ordered based on the department ID, right? It's not based on that. And I want to do a secondary index based on this department ID for the students, for the student record. You can have many other fields. So let's see my index file. Okay, so in the first approach, I can do this. So I see 1, 1, 1. So I'm going to have 1 here, 1 here, 1 here. So I'm going to have duplicated things here for the value, but the pointer are different. So the first one going to point to this record, this one going to point to this record, and this one point to this record. In other words, every single one show me directly which block to go. Okay, so that's the first one for each record. Okay, and then I have number 2, right? Remember, this must be ordered, okay? Otherwise, it's meaningless to waste extra space. Remember index files, right? Take extra space, right? The reason we have index because it can help us to speed up the search. And so we have 2 and the 2 of them. So this is pointer here, this is a pointer here. And then number 4, we're going to do the same way, right? So we have number 4, actually 2 of them. And 1, 2 here, and the other also point to here. Okay, so that's for this one. So let's see the second one. The second one is we have a variable length record for the index 1 index entry, and we have the same k, the value only once, but this one has a couple of them. So I'm going to modify this. The second way to handle this is I have the same data file, right? So what I'm going to do is I'm going to use distinct value for each. So I have number 1 distinct, and number 2, and number 4, and number 8, right? So that's the one I have. And then instead of 1 pointer, I'm going to have a variable length for pointers, okay? And how many, it depends on how many I have. Like number 1, I have 1 and 2 and 3, right? So number 1, I have 3 pointers. And number 2, I have 1 and 2 pointers. So how many pointers I have? This size, the size of this is not fixed. Depends on how many you can have. So you can have a list of pointers. So 1 to k depends on how many you have. Okay, so that's for the secondary index on the another way to handle same situation. Remember, all of this is because we want to do index on non-key field, right? This number is not unique. The next one, the third one is if we have so many pointers, so say we have so many students for computer science, so many students for triple E, so we have so many, then how about we just reserve a block for all the pointers for that particular value? So we have a block of record pointers. So here, so this is a good one to show. We have the field like 1, 2, 3, and that's safe. So this is the example of using department number for employee. So we have those numbers here, and remember they are not ordered, right? So they are not ordered and they are not unique, right? So I build this, so I have many with number 1. You know, I see number 1 here, many with number 1. So I'm going to using the block pointer point to this whole block, and this block holding everything for number 1, and this holding everything for number 2, this holding everything for number 3. Okay, so that's for this. So up to this point, we finish all the single level index. So what is single level index? Means you have an index. So you have an index, and the index point to the data file directly, right? So this is the only thing a little bit different. This is actually point to a block rather than the block directly, but this is only for the storage of pointer purpose. So all of them actually an index point to the data file directly, and that's something called the single level index. And for the single level index, we cover the primary, secondary index, right? And also clustering index. For each of them, you need to know when we have particular structure, how can we, what type of index can we build? Okay, so let me give you a quick in-class exercise. So let me see if I have something. Okay, so let me just using, actually you don't need a picture. Maybe I should do something to avoid confusion. Let me just write down things. Let me put this, okay, sorry, not right. Okay, let's do a quick in-class exercise and to see if you understand everything or not. Okay. Okay, so say I have a data file, okay, and suppose you cannot change my data file. My data file is about student, okay, about student information. And in this data file, okay, this data file is physically ordered based on student ID. Okay, so this data file physically ordered based on student ID. And for student record, what kind of field I have? I have a student ID. And this is also unique, right? This is unique. So this is my primary key. And I have student name. And I also have student address. Okay, so student have this and the physical order on student ID. And my question here is, first of all, can we build the primary index on this data file? Okay, remember you cannot change the structure of the data file. And in this, regarding this data file, is that possible to build a primary index? So if yes, okay, which field or which attribute, right? Okay, we use to build a primary index. My second question is, can we build a clustering index on that? And if yes, which, right? Which field? And the third one is, can we build a secondary index on that? And if yes, which field? And so each of them can be, field or fields, which one you feel, whether you can do one index or two, you can decide. So I'm going to give you, let's see, 3 minutes on this. How about that? Now let's see this one. Let's see if we're able to answer it. So for primary index, we require the data files to be physically ordered on a key. And this is right? It's physically ordered on student ID, and student ID is a key. And so that's why we can build a primary index on it. And that is student ID, right? So this is a yes, and this is on student ID. And then let's see the clustering index. this one require student, require data file, right? The student data file must be physically ordered on a non-key. And that is not true because you already gave the given thing is it's a physical order on key. It's not on non-key. So this is no. And then for secondary index, remember if anything that's not covered by primary or clustering, it can be covered by secondary. So the answer is yes. So let's see student ID that is already primary index, right? So it shouldn't be secondary anymore. However, name here, we can build a secondary index on it, right? So this is one secondary index, right? So you say you can have this is my data file. So I already have primary index on this, and I have another index that's on name, right? You can have index on that. I can build another index on address also. So you can have another index on the address here. Okay, so that's for this exercise actually summarize what we learned for the 3 type index. So in reality, do we build index all the time? Do we build the index all the time, or when should we build the index? So you should build the index on the things that are frequently queried, and especially if you join on something frequently, like a 2 attribute join, right? And like is this A equal to B, right? And that's something also you want to consider. And index also really helpful when we do filtering, right? So we say we want to see employees start date is more than or like greater than which year, month, things like that. So those things are useful when you do index. But we also can see index taking space, right? And the maintain index also has overhead. So when you insert something, the index maybe corresponding need to do adjustment, things like that, right? Although we talk about like different way to make things easier, but still, we have cost to maintain the index. So it's not good practice to index on everything. It just when you see the application, you see what type of query frequently running on, and it is a good thing to think of which one you want to put the index on. So many DBMS, they automatically add index on the primary key already, but you also can create your index directly. The syntax on creating index can be different in different DBMS, and in general, they ask you which table to work on, which attributes, right? So in general, the index, the syntax to create it is more like create index, and then you give a name for the index, just like you create table, you give a name for the table, right? You create table for that on, and then you specify the table name. So because it's like common sense, right? You need to tell the DBMS which table you want to do index on. So on which table, and then you tell them which column you want to do index, right? It can be index on one column, also can be a combination of different columns together to do index. And you can also, they also allow you to, many of them also allow you to do index on, like, for example, when you can do alter table, to add index, things like that. And many of them doesn't require to specify which type of index. And this is the one actually I mentioned, before, when you try to give a particular name for the index, because of different DBMS, they can support a slightly different, they can support like different type of index, not necessarily just single level we mentioned. They can have different terms, so make sure you check their user manuals in order to give the right name for index. Okay. Okay, so that's for the single level. And what is a multi-level index? This is the one we can use more than one level index to point to the data file. So like this example, we have one level index point to another level index and then point to the data file. So you have more than one level of indexing compared to single level, one index data file. Multi-level is one index, another level, and then data file. And of course, this is only 2 level. We can have many level like this. And the whole purpose of this is when we build a structure, the multi-level structure like this, we be able to search in the very top level and we can find a pointer. We can find a pointer and this pointer lead me to the next level. And then you see in the next level, right? So in this level, the very top level only have one block. So when I think about disk IO, I only need one block, loading one block, right? And I can search within the block to see, oh, this is a pointer to follow. Then in the next level, I also only using one block because the pointer already tell me which block to go. And then I keep continue this until the data file, okay? So you can have many level until the data file. And then you also need one block. So each level only need one block access one block, right? And then you can get the data file. So so the sacrifice, we sacrifice the space means we spend space, take space on the different levels, take space, but hopefully the one block per level help us to gain the performance. So that's the concept of a multi-level index. Okay, that's all.